All right, our next relationship we're going to look at is what happens when we have a perpendicular and an angle bisector. So the perpendicular bisector theorem says if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So this is the perpendicular bisector. We can tell it is CD is perpendicular to AB, and we know that it's perpendicular because it is got a right angle here. And we know it bisects this segment AB because DB is congruent to DA. So those things have to happen here. So if CD is perpendicular to AB and AD is congruent to DB, then we know that the length from A to C is going to be the same thing as B to C. And then the converse of this says if a point is equidistant from the endpoints of a segment, then it's on the perpendicular bisector. So if they give us that these two are the AC is congruent to BC, and we know it's a right angle here, okay, so that means it's perpendicular, CD becomes perpendicular to BD, then we know that AD is going to be the same thing as BD. So those will be the same. So in a lot of these problems here, we're just going to be setting things equal to each other. All right, so let's look here. If this is our given situation, we have these are bisected because it's cut in half. We know it's perpendicular, so it's perpendicular bisector. Therefore, we know 7x plus 24 is equal to 13x minus 48. Okay, then we go back to solve. So we're going to subtract 7x, and we're going to add 48. Okay, this is going to give us 72 on the left. And on the right, I'm going to get 6x, because 13 minus 7 is going to give us 6. We're going to divide by 6. And therefore, x is equal to, is that 12? Okay, now, all we're looking for here is the value of x, so we know we're done. You can always plug it back in to check to see if they're the same. All right, so let's look at the next one here. So this is on the perpendicular bisector here because this is perpendicular. These two are the same, so this is using the converse, which means that these two segments are congruent. So once again, set them equals 17x minus 3 is equal to 9x plus 13. So we start by subtracting 9x, bring our x's to one side, bring our numbers to the other, so we'll bring 3 to the other side. 16 is equal to 8x divided by 8. X is equal to 2. All right. So I want you to try some of these on your own. So pause the video, come back and check your work when you're done. All right, so one thing we're looking at here, we have a right angle here, so it means it's perpendicular to it. It cuts it in half, so it's a perpendicular bisector, which means that these two segments are the same. So 7x minus 22 is equal to 4x plus 5. Solve for x by subtracting our x's to one side. Get our numbers on the other. So we get 27 is equal to 3x divided by 3. X is equal to 9. Now, the second part of this, we got to find RS, which means I'm going to take 4 times 9 plus 5. Well, that's 36 plus 5, which is 41. So that length of that is 41. All right, so this one we're looking for EG, this segment up here. And one thing we know about these two is that they are the same, because this is segment bisector here, this is a perpendicular bisector. So we can say that EG is going to be congruent to GF. So we can set these equal. 2x plus 11 is equal to 14x minus 37. Subtract 2x, add 37. That's going to be 48 is equal to, this will be 12x by 12, and x is equal to 4. So find EG. We go back over here and plug it in. So EG is equal to 2 times 4 plus 11. 8 plus 11 gives us 19. So EG is equal to 19. All right, looking at AB here, looking for AB, which is that full length. We know that we're looking at this and this and this. Okay, lets us know it's on the perpendicular bisector here. So which means that 5x minus 11 is equal to 3x plus 17. So get our x's to one side, so 3x, add 11, 2x, 11's and 3x cancels, which gives me 28, 5 by 2, x equals 14. So now we're looking for AB, which is the full length here, so we need to plug this into one side, and then we can double it. So AD is equal to 5 times 14 minus 11. So 5 times 14 is 70. Subtract 11. She gives 59. So length from AD is 59. So that means that if this is 59, then this is also 59. So we can add those together. And that's going to give us 118. So 118 is the length of AB. All right, so let's look at the last one on perpendicular bisectors. So we know that these two are congruent. So we take 6x minus 26 equal to 3x plus 34. All right, so we're going to subtract 3x over. We're going to add 26. So we're going to get 3x is equal to, let me look over here, we're going to get 60. And then we divide by 3. X is equal to 20. Now, for JK, 6 times 20 minus 26. 120 minus 26. And that's going to give us 94. So we got two answers, one with 20, one with 94. All right, so now let's move to angle bisectors. All right, so let's look at angle bisectors. So the angle bisector theorem says if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So looking at here at AD, AD is the angle bisector. So that means that any point on here is going to be equidistant. And the way we check distance, the quickest, shortest way from one point to a line segment is across a perpendicular segment, like the ones we have BD and CD. So no matter where I went on this, I could go to right here, and I could draw a line. If I'm going to draw a line to this side, the shortest distance is the perpendicular distance, which goes like this. So these two line segments would then be the same. So the converse of the angle bisector theorem says if a point is on the interior of an angle and equidistant from the sides of the angle, then the point is on the angle bisector. So now that we see that BD is congruent and perpendicular, and CD is perpendicular and congruent, then we know that AD bisects angle BAC, or it may say AD is the angle bisector of angle BAC. So let's look at some examples again, similar to the other ones. We know that if these are congruent and these are perpendicular, which means that these segments have to be the same. So 4x plus 30 is equal to 9x minus 5. Subtract 4x. We're going to add 5. 35 is equal to 5x. 5 by 5, x is equal to 7. So that's all we had to find there. Let's take a look at the next one. Okay. Notice this is congruent to this. This is perpendicular, which means this is the angle bisector. This line right here, angle bisector, which means that these two angles have to be the same. So 5x minus 11 is equal to 8x minus 41. So we'll bring the 5x over. 41 we're going to bring the other side. Okay, this gives us 41 and negative 11, which makes it 30, is equal to 3x. Divide by 3, x is equal to 10. Okay, so now let's look at the next one here. This one we're looking to find the length of AD, which is this segment right here. All right, so one thing we know here is that these, based on the information given, these two should be congruent. So 13x minus 4 is congruent, or say equal to 8x plus 11. So once again, we're solving for x. And so we're going to bring the smaller x to the larger x. That's going to give us a negative 8. Add 4. So we get 5x is equal to 15. When we divide by 5, that gives us x is equal to 3. So looking for AD, so AD is equal to 13 times 3 minus 4. So we're going to multiply this by 3. It gives us 39 minus 4, which gives us 35. So AD is equal to 35. So you guys try number 4. Pause your video, check your answer when you're done. All right, so let's see how you did. You should get 7 for x and 24 for the measure of angle XWZ. So be careful, because sometimes they may ask you to find the entire angle. So if we know that this is 24, and they're congruent, that would be 24, which means the whole thing would have been 48. So always make sure you read carefully what they're asking for. All right, let's look at number 5. So in this problem here, we know that this is the angle bisector. These are perpendicular here to it, to the side. Therefore, these two are the same, angle bisector here. So that means we're going to take 2x plus 20 equal to 5x minus 37, and they're asking us to find f, g, h. So they're looking for the entire angle this time. So we're going from here all the way to here. So to solve for x, we're going to subtract 2x, add 37. That gives us 57 is equal to, so these cancel. And let's see here, that cancels, give me a 3x by 3, and x is equal to 19. So we've got our x. To find this, we plug it back into either one of these. So I'm going to do 2 times 19 plus 20. That's 38 plus 20 is 58. So if this is 58 and this is 58, then we take 2 times 58 to find our angle FGH, and that should give us 116. So 116 is our entire angle measure. All right, let's try our last one here. Once again, if this is the angle bisector, these two are the same length, so 7x minus 40, there should be a 7 there, okay, equals 5x minus 8, subtract 5x, 2x minus 40 equals 8, or negative 8, add 40, 2x is equal to 32, divide by 2, x is equal to 16. So that's our first part. We're looking for QR. So for QR, we're going to take 5 times 16 minus 8. So 5 times 16 is going to give us 90 minus 8 is 82. Oh, I mismultiplied here. That should be 80. That makes that 72 if we subtract it. So this is 80, and this should be 72. All right, so this concludes our lesson on the perpendicular and angle bisectors of a triangle.